So what if we want to know what is the mass of one atom of carbon-12 in grams? Pretty difficult to measure just on a balance because it's very difficult to obtain just a single atom. But what if I knew if there was a conversion between atomic mass units, so the units that we're used to on the periodic table, and grams? Well, it just so happens that I have such a conversion. Okay, you could find it as well. Just use this value if you ever needed it. Okay, we're going to say that one atomic mass unit is equal to 1.6606 times 10 to the power of negative 24 grams. You do not need to remember this number in any way, shape, or form. Okay, so if I want to know the mass of a single isotope of carbon-12 as a mass of 12 atomic mass units, let's multiply that by this conversion factor. Okay, so we'll say 1.6606 times 10 to the negative 24 grams over one atomic mass unit. Our atomic mass units will eliminate one another. So I'm basically saying 12 times this 1.66 number. Alright, on your calculator you're going to want to learn where the EXP or capital E button is. Okay, negative 24. Do it on the computer, it actually shows me all the decimal places. Alright, so I'm going to write this in. I'm going to say, okay, 1.99272 times 10 to the power of negative 23 grams. That's the mass of a single carbon atom, and that's great. But that's incredibly impractical. There's no balance that I could possibly have for our class or lab that could measure this. So I'm going to throw a random number at you. What about the mass of 6.02 times 10 to the power of 23 carbon atoms? Alright, well, why this number? Well, there's a scientist by the name of Amedeo Avogadro showed that in exactly 12 grams of carbon-12 there were exactly this many atoms. This number is now known as a mole. Okay, the same as a dozen is 12. A mole is 6.02 times 10 to the power of 23. So, what about the mass of this many carbon atoms? So I'm going to take a single carbon atom, and I'm going to multiply by that many carbon atoms, and we'll see what mass comes out. Okay, so grams per atom of carbon. I'm going to multiply by the number of carbon atoms, which will mathematically eliminate the unit of atom. Okay, and what I should yield is the mass of 1 mole of carbon atoms. Okay, so that identity of a mole, 6.02 times 10 to the 23, is the unit now known as mole. Find that I get 11.9961744, which, let's round this to 2 decimal places. This is 12.00 grams. So, just put all this on here for completeness. 12 atomic mass units now that you would have added up from the periodic table doing molecular mass. This really we're going to express as the unit grams per mole. So I can start to use this to figure out how many atoms, let's say I'm working with atoms or molecules, what have you, right, as long as I'm able to get an actual mass for the substance. Okay, so the masses are the same on the periodic table. They can either be expressed as grams per mole or atomic mass units.